Now we are going to start class 10th, the chapter electricity. We have already discussed some points of electricity, that is electric current, how the current flows through a conductor, what are the different type of materials, how can we classify them, what are the different types of the current, AC and DC, their advantages, disadvantages, and all these things. We have already discussed in the previous lecture. Now, we already discussed what is electric potential, what is electric potential difference, how electric current flows through the conductors. Let us just take a very quick overview. So what is electric potential? It is defined as a amount of work done in bringing a unit positive charge from infinity to a point. That means we bring a unit positive charge from infinity to a point. So work is done there. So that work done on a unit charge, to move a unit charge, that is stored in the form of electric potential. It is represented by V. So V is equals to work done per unit positive charge. It is a scalar quantity and its SI unit is volt. SI unit is volt, which is represented by V. The instrument or the device which is used to measure potential is voltmeter. Okay? So voltmeter is a device. Now we have potential difference. It is a difference of the electric potential of the 2 points. We have these 2 points, A point and B point. This have the potential VA, this have the potential VB. We bring the charge from infinity to a point, this point, then from this point to this point. So it have a potential VB, it have a potential VA. The difference of the potential of these 2 points is known as potential difference. So VA minus VB, or we can say VB minus VA. This is potential difference. In a cell or a battery, we draw like this. One is positive terminal, another one is negative terminal. So what does a positive terminal indicates? It is having higher potential. It is having higher potential. And the negative terminal, that means having lower potential. And the difference of these two potential is known as potential difference, which we represented by simple V or delta V. Delta represents the change or the difference, right? Suppose it is having 100 volt potential, it is having 10 volt potential. The difference of the potential of these 2 points is 90 volt. So potential difference is 90 volt. Understood? So that is a potential difference. It is a potential difference of the 2 points. दो points की potential का difference is potential difference. Due to this potential difference, when we applied or connect a battery or a cell across the ends of the conductor, then due to this potential difference per unit length, the electrons which are initially moving in the random direction, they start moving in a particular direction. This potential difference per unit length provide them a drift, a velocity through which they can move from one point to another point, that is from negative to the positive terminal of the battery. This is how the current conduct in the conductors. So this is a potential difference. The instrument, if we talk about, it is also a scalar quantity. Okay. Scalar quantity. Its SI unit is same as that of potential, that is volt. And the instrument used to measure it is voltmeter. Instrument or device used to measure it is voltmeter. Voltmeter is always connected in parallel in the circuit. Parallel in the circuit. Just like this is resistance, so across the resistance it is connected in parallel. Why it connects in parallel? Because it has high resistance. And the resistance of ideal voltmeter is has infinite resistance. Infinite resistance, right? Next topic we have is Ohm's law. So what is Ohm's law? when we applied the potential difference, अभी मैंने आपको बताया how we applied the potential difference across the ends of the conductor by connecting some cell or battery. ठीक है, सेल और बैटरी कनेक्ट करने से that means we provide the potential difference, और potential difference do the work done to move the charges in a particular direction so that current will be conducted across the conductor. So we provide the battery, that means electric field, that means potential difference per unit length to do the work done to move the charges in a particular direction. So what is Ohm's law? It states that the potential difference applied across the ends of the conductor is directly proportional to the current flowing through the conductor by keeping temperature and area of cross section constant, right? So जो भी हम पोटेंशियल डिफरेंस अप्लाई करते हैं, जैसे ही हम पोटेंशियल डिफरेंस अप्लाई करेंगे, वर्क डन होगा यहाँ पे टू मूव द चार्जेस इन अ पर्टिकुलर डायरेक्शन, दे स्टार्ट फ्लोइंग इन अ पर्टिकुलर डायरेक्शन एंड हेंस द करंट इज कंडक्टेड थ्रू द कंडक्टर. So that means जितना हम पोटेंशियल डिफरेंस अप्लाई करेंगे that is directly proportional to the current flowing through the circuit. अगर हम पोटेंशियल डिफरेंस इंक्रीज कर देंगे तो करंट भी इंक्रीज हो जाएगा. So this is Ohm's law, that is V is directly proportional to I. When we remove this proportionality sign, V is equals to IR. What is R? R is the proportionality constant known as resistance of the conductor. Proportionality constant called resistance of the conductor. Resistance of the conductor, right? That means R is equals to V upon I. If we plot as it states कि V is directly proportional to I, so when we plot a graph between the potential difference and the current, between the potential difference and the current, what we got? We got a straight line. This is R. So R is equals to V upon I, and we can represent the slope with tan theta. So R is equals to V upon I is equals to tan theta. ठीक है? If we have given in a question, so this is Ohm's law. If we have given the question, this is V, this is I. It is given, ठीक है? A and B. We have given two slopes. You have to tell me which one is greater. So how you can tell? There are two ways to find if angle is given. ठीक है? Suppose angle is given, it is 30 degree and it is 60 degree. It is 60 degree. So you can tell with the angle tan theta. उससे आप compare कर सकते हो. Another method, if angle is not given, then how you can tell which one slope is greater or which one is lesser? By the value that what is R? R is equals to V upon I. ठीक है? So V is directly proportional to R. If the value of V is greater, then the value of R is greater. So in this, slope B is greater. Okay. So this one is greater. So these type of questions may be asked from the Ohm's law. So what is Ohm's law? V is directly proportional to I. That means potential difference applied across the ends of the conductor is directly proportional to the current flowing through the conductor. That means V is directly proportional to I, V is equals to IR, or R is equals to V upon I. This is Ohm's law. So next we have resistance. We talk about resistance. What is resistance? So it is an intrinsic property. It is a property of the conductor. It is a property to oppose the electric current, to oppose the electric current in the electric circuits या in the through the conductors, in the electric circuit or across conductor, right? So property which oppose the current is known as resistance. What are resistors? Some students got confused ki what are resistor, what is the difference? These are two things or having same thing. So what is resistor? It is a device, instrument or device, electrical instrument or electrical device which offers the property resistance. So it is device or component, we can say electrical component to offer resistance. Okay. Symbol of resistance is like this. It is fixed and it is variable. You can say rheostat. So rheostat is example of variable resistance. It is variable resistance. Right? It is fixed resistance. So we can also find the value of the resistances by the color coding. They are having different values. So it is resistor. Resistor is an electrical component or the device which offers resistance, and resistance which oppose the electric current through the electric circuits या through the conductors, right? तो current को रोकने का जो काम करता है, that property is known as resistance. It is represented by the letter R, and its SI unit is ohm. SI unit is ohm, which is represented by the Greek symbol, this. So it is resistance. Next we have, so what is the relation? R is equals to V upon I. From this relation, we can say that R has a direct relation with V, that means potential difference. If we increase the potential difference, that means R also increases. But the resistance have the inverse relation with I. If we increase the resistance, then current through the conductors decreases. If we decrease the resistance, current increases. So there is an inverse relation of current with the resistance, right? Next, what are the different factors on which the resistance of a conductor depends? Factors affecting the resistance of a conductor. So what are the different factors? There are 4 factors which affect the resistance of a conductor. Number 1, length. How the length affects? Resistance is directly proportional to the length of the conductor. Right? Resistance is directly proportional to the length of the conductor. If we increase the length of the conductor, resistance is increases. If we decrease the length of the conductor, resistance of the conductor is decreases. सिर्फ length की हम बात कर रहे हैं. So it is directly proportional to L. अगर हम length को twice कर देते हैं, then resistance is also 2 times the original resistance. अगर हम half कर देते हैं तो resistance is also get half. Right? So this is the first factor. Second factor is area of cross section. Area of cross section. How the area affect the resistance of the conductor? Resistance is inversely proportional to the area of cross section. If area of a wire is greater, then the resistance is less through that conductor. That means area greater, that means we have a thick wire. We have a thick wire. And area less, that means we have a thin wire. Thin wire. So area less, that means offers more resistance. So the question may be asked कि through which wire among thin and thick current flow more easily. Current आसानी से flow करेगा, यानी कि resistance कम होगा. तो कौन सी में से होगा? Thick wire. That means area is more, resistance less. तो current flow more easily. तो current flow more easily through thick wire. ठीक है? Current flow more easily through the thick wire. क्योंकि thick wire में क्या होगा? एरिया ज्यादा होगा. एरिया ज्यादा, रेजिस्टेंस लेस. रेजिस्टेंस लेस मतलब करंट मोर, करंट फ्लो इजीली. इफ वी टॉक अबाउट थिन वायर, एरिया कम होगा, इट ऑफर्स ग्रेटर रेजिस्टेंस. दैट मीन्स करंट जो है वो कम फ्लो करेगा. तो मोस्टली जो हम ट्रांसमिशन वायर्स होती हैं जिनमें हमें चाहिए कि करंट इजीली फ्लो करे, तो देयर वी यूज थिक वायर्स. राइट? सो अगर हम एरिया को चेंज करते हैं, एरिया ज्यादा करेंगे तो रेजिस्टेंस कम हो जाएगा, और एरिया को ज्यादा करेंगे तो रेजिस्टेंस कम. सो एरिया हैज अ इनवर्स रिलेशन विद द रेजिस्टेंस ऑफ द कंडक्टर. नेक्स्ट ऑन दीज टॉपिक्स द क्वेश्चन में भी आस्क्ड कि अगर वायर को स्ट्रेच किया गया है, तो इफ यू स्ट्रेच द वायर, तो स्ट्रेचिंग में क्या होगा? द डेंसिटी एंड द वॉल्यूम रिमेन सेम. वॉल्यूम तो सेम रहेगी, राइट? वॉल्यूम सेम रहेगी, यानी कि इफ यू स्ट्रेच तो लेंथ तो इंक्रीज हो जाएगी, बट एरिया क्या हो जाएगा? रिड्यूस हो जाएगा बाय द सेम फैक्टर. दीज टाइप ऑफ क्वेश्चंस में बी आस्क्ड कि इफ वी स्ट्रेच द वायर, if we stretch the wire, ठीक है, length is increased by, length is increased twice. Length is increased, your length is doubled or twice increased twice. Then find the new resistance. New resistance. So how you have to solve these questions? Length, if you stretch the wire, अगर आप रबर बैंड को स्ट्रेच करते हो तो लेंथ इंक्रीज हो जाती है, बट सेम टाइम पे एरिया ऑल्सो रिड्यूसेस. ठीक है? इफ वी हैव दिस वायर, इफ यू स्ट्रेच इट, अगर आप इसको स्ट्रेच करते हो, इसी को स्ट्रेच करते हो, तो एरिया इज रिड्यूस्ड, एरिया इतना हो जाएगा लेकिन ये लेंथ में डबल हो जाएगी, राइट? सो दिस पोर्शन इंक्लूडेड देयर, सो दिस हैपन, यानी कि वॉल्यूम रिमेन्स कांस्टेंट, ठीक है? वॉल्यूम इज रिमेन्स कांस्टेंट. व्हाट इज वॉल्यूम? इट्स ए एल. वॉल्यूम में क्या होता है? एल क्यों होता है? तो एरिया वी हैव 2L और लेंथ और ब्रेड्थ देन अनदर L. सो ए एल. अगर आप एक फैक्टर को इट रिमेन्स कांस्टेंट, वॉल्यूम तो कांस्टेंट रहेगी, आपने कुछ अनदर ऐड नहीं किया कोई मटेरियल, सिर्फ आपने स्ट्रेच किया, तो स्ट्रेच करने की वजह से लेंथ इंक्रीज होगी तो एरिया रिड्यूसेस बाय द सेम फैक्टर जितने से आप लेंथ को इंक्रीज कर रहे हो. या वाइस वर्सा भी हो सकता है कि अगर आप इसको 2 टाइम्स फोल्ड कर दोगे तो यहां से एरिया इंक्रीज हो जाएगा उतने ही फैक्टर से और लेंथ रिड्यूस हो जाएगी. सो व्हाट हैपन? इट रिमेन्स कांस्टेंट, वॉल्यूम इज इक्वल्स टू AL. दिस वॉल्यूम रिमेन्स कांस्टेंट, A is equals to L. That means they have inverse relation. अगर आप जितने फैक्टर से लेंथ को इंक्रीज करोगे उतने ही फैक्टर से एरिया reduces, right? So in this question, length is twice of original length, right? अभी मैंने आपको बताया जितने फैक्टर से लेंथ इंक्रीज करोगे उतने ही फैक्टर से एरिया रिड्यूस हो जाएगा. रिड्यूस मतलब अपॉन. So A dash is हाफ ऑफ द ओरिजिनल 1/2. यहां अगर ट्वाइस हो रहा है तो यहां भी डिवाइड हो जाएगा 2 से. अगर लेंथ थ्राइस करोगे, 3 टाइम्स करोगे तो एरिया भी रिड्यूस हो जाएगा 3 टाइम्स. अगर इसको 4 करोगे तो एरिया हो जाएगा 4 टाइम्स रिड्यूस, यानी कि 1/4. ठीक है? रिड्यूस मतलब डिवीजन में, डिनोमिनेटर में, और इंक्रीज मतलब न्यूमरेटर में वो फैक्टर आएगा, राइट? सो देन ठीक है, so when we put the values in this, when we combine these two factors, what we have? R is equals to L upon A. When we remove the proportionality sign, we got rho. हमारे पास एक फैक्टर आएगा rho. So R is equals to rho L over A. ठीक है, this is R जो इनिशियल रेजिस्टेंस था. R डैश यानी कि चेंजेस होने के बाद it's rho L dash over A dash. When we took the ratio of this equation 1 and this equation 2, so R dash upon R is equals to, put the value of R dash, rho L dash we have 2L, यानी कि length is twice, doubled in comparison to the original one. Then area is reduced by half, so A2 goes up. This is rho dash, this is R dash. What is R? It's being area over rho L. जो भी चीजें कैंसिल आउट होती हैं, cancel them out. So rho is cancelled with rho, area with A, L with L. What we have? 4. That means original ये after changes R dash is equals to 4. It goes up. तो R dash is equals to 4 टाइम्स ऑफ R ओरिजिनल वन, यानी कि न्यू रेजिस्टेंस जो होगा वो 4 टाइम्स हो जाएगा द ओरिजिनल रेजिस्टेंस की, राइट? अगर आप 2 फैक्टर से इंक्रीज करते हो. द डायरेक्ट फॉर्मूला फॉर दिस इज टू फाइंड द न्यू रेजिस्टेंस R डैश इज इक्वल्स टू n स्क्वायर ऑफ द R. n इज अ फैक्टर कि आप कितने से इंक्रीज कर रहे हो. अगर आप उसको 2 टाइम्स यानी कि डबल हो गई है लेंथ, देन R डैश इज इक्वल्स टू 2 स्क्वायर ओवर R यानी कि 4R. इफ n is 3 यानी कि थ्राइस 3 टाइम्स लेंथ अगर आप इंक्रीज कर रहे हो, स्ट्रेच कर रहे हो उसको 3 टाइम्स, देन R डैश इज इक्वल्स टू स्क्वायर इज 9 टाइम्स ऑफ R. और R की कुछ ना कुछ वैल्यू भी दी जा सकती है कि ओरिजिनल वन रेजिस्टेंस इज 10 ओम, तो 10 मल्टीप्लाई बाय 9 इट्स 90. ठीक है? इफ इट इज 4 टाइम्स देन R डैश इज इक्वल्स टू 16R. This is the direct method. But you understood now कि how this affect, right? अगर हम उसको stretch करते हैं तो बिना कहे लेंथ डबल हो गई, but area is reduced by the same factor. area भी कम हो जाएगा बिना ही कहे, right? This is how we solve the questions to find the new resistance. Now we have completed the 2 factors. The third one factor we have. Third factor we have, yeah, from these 2 factors we have a physical quantity. What is that? that is resistivity. First of all, we covered it that resistivity. So what is resistivity? It is also known as specific resistance. Specific resistance. So specific resistance, it is specific resistance. It is specific resistance when the length of the conductor is 1 meter and its area of cross section is 1 meter square, right? That means we have, when we combine, we have R is directly proportional to L, है ना? अभी हमने factors में किया है, and R is inversely proportional to area of cross section. When we combine these two equations, combining equation 1 and 2, what we have? R is directly proportional to L over A. When we remove the proportionality sign, what we have? R is equals to rho L upon A. ठीक है? Or when we rearrange this equation, rho is equals to R A over L. What is this rho? This is resistivity of the conductor. That means specific resistance. ठीक है? This is resistivity यानी कि specific resistance. If in this we put area is equals to 1 meter square and length is equals to 1 meter, then rho is equals to R. तो specific resistivity क्या है? Specific resistance है when the length of the conductor is 1 meter and the area of cross section is 1 meter square. यानी कि resistivity को हम specific resistance ही कह सकते हैं जब length 1 meter होगी and its area of cross section is 1 meter square. This is resistivity. It is a scalar quantity, and if we talk about its SI unit, then the SI unit of, if we put in the formula, in this formula, SI unit of resistance is ohm, area is meter square, and length is meter. Meter is cancelled out with meter, so its SI unit is ohm meter, right? Ohm meter. It is resistivity. Next. So now we are talking about what are the different factors on which resistance depend. So resistance depends on the length, second area of cross section, third factor on which the resistance of a conductor depends, that is temperature. Okay. Here we only talk about the dependency of resistance on the temperature of the conductors. सिर्फ हम conductors की बात कर रहे हैं. Yeah, metals. Most of generally metals are good conductors of heat and electricity. So in case of conductors, when we increase the temperature, their temperature coefficient alpha is positive. Metals का या conductors का जो temperature coefficient होता है alpha, that is positive. So when we increase the temperature, the resistance of the conductors is also increases, right? So this is how the temperature effect. अगर हम temperature increase करेंगे तो conductors का resistance भी increase हो जाएगा. If we decrease the temperature, then their resistance decreases in case of conductors. So this is how the temperature affect the resistance. Fourth factor which affect the resistance of a conductor is nature of the material. Nature of the material. What type of nature the material have? That means here we talk about the number of electrons, यानी कि number density, number of electrons per unit volume. If a material having more number of electrons, more number of current carriers, then the resistance reduces. That means R has an inverse relation with number of electrons. If a conductor or a material having greater number of electrons density, then resistance decreases. If we talk about silver and aluminium, which one is more conductor? So silver is a more conductor, better conductor. So these are the four factors on which the resistance of a conductor depends: length, area, temperature, and nature of the material. Only liquid which is conductor is mercury. Okay. Next we have, what are the different factors on which the resistivity of a conductor depends? Factors affecting the resistivity. Factors affecting the resistivity of a conductor. So remember one thing, resistivity does not depend on length and area of cross section. Resistivity does not depend length and area of क्रॉस सेक्शन. लेंथ और एरिया में अगर कंडक्टर की कोई भी चेंजेस आता है तो रेजिस्टिविटी पे कोई इफेक्ट नहीं होगा. रेजिस्टेंस में चेंजेस होंगे, जैसे हमने देखा था कि अगर हम लेंथ को इंक्रीज कर रहे हैं 2 टाइम्स, एरिया इज आल्सो रिड्यूस्ड बाय द फैक्टर 2, तो न्यू रेजिस्टेंस जो था वो 4 टाइम्स हो गया था टू द ओरिजिनल रेजिस्टेंस, यानी कि 4 टाइम्स हो गया था. बट रेजिस्टिविटी में कोई चेंजेस नहीं होंगे, देयर आर नो चेंजेस इन द रेजिस्टिविटी. तो फिर कौन से फैक्टर्स पे डिपेंड करती है रेजिस्टिविटी? नंबर 1, टेम्परेचर. अगर आप कंडक्टर का टेम्परेचर इंक्रीज या डिक्रीज करते हो तो उसकी रेजिस्टिविटी चेंज होती है. कैसे चेंज होती है? अभी हमने देखा था R इज डायरेक्टली प्रोपोर्शनल टू रो, यानी कि डेंसिटी जो होती है वो डायरेक्टली प्रोपोर्शनल थी रेजिस्टेंस की. जो चेंजेस रेजिस्टेंस में आ रहे थे विद द इंक्रीज इन द टेम्परेचर या डिक्रीज इन द टेम्परेचर, वही चेंजेस रेजिस्टिविटी में आएंगे. यानी कि विद द इंक्रीज इन द टेम्परेचर, अगर रेजिस्टेंस इंक्रीज हो रहा था कंडक्टर्स का, सो रेजिस्टिविटी आल्सो इंक्रीजेस. सेकंड, नेचर ऑफ द मटेरियल. नेचर ऑफ द मटेरियल. तो नेचर ऑफ द मटेरियल में भी जैसे जैसे चेंजेस रेजिस्टेंस में आ रहे थे सेम ऐसे ही होगा. सो रेजिस्टिविटी इज आल्सो इनवर्सली प्रोपोर्शनल विद द नंबर ऑफ इलेक्ट्रॉन्स पर यूनिट वॉल्यूम, यानी कि नंबर डेंसिटी. सो अगर नंबर ऑफ इलेक्ट्रॉन ज्यादा होंगे किसी मटेरियल में तो उसकी रेजिस्टिविटी कम होगी, यानी कि उसकी कंडक्टिविटी ज्यादा होगी, वो बेटर कंडक्टर होगा, राइट. So these are the 2 factors on which the resistivity depends. But one confusing is कि अगर लेंथ या एरिया में चेंजेस करते हो तो रेजिस्टेंस में चेंजेस आता है. देयर आर नो चेंजेस इन द रेजिस्टिविटी ऑफ द कंडक्टर्स. सो न्यूमेरिकल्स में बी आस्क्ड फ्रॉम दिस कि इफ अ बल्ब इज कनेक्टेड विद द पावर सप्लाई, इज कनेक्टेड with the power supply, is given 220 volt. The resistance of this bulb is 20 ohm. ठीक है, resistance of this bulb, it is bulb's resistance. ठीक है, find the current across the bulb. So current you have to find. So what is given? Resistance of bulb is given 20 ohm. Then power supply you have given 220 volt. You have to find current. So using Ohm's law, R is equals to V over I. You have to find I. So I is equals to V over R. Put the value of V, that is 220. R, it's being 20. So 11 ampere is the value of current across the bulb. So among these 3 quantities, R is equals to V upon I. 2 are already given in the question on the numerical and 1 is asked. So you can easily find that. Okay? So this is how we end today's lecture over here. Remaining topics we will cover in the upcoming lectures. So thank you.